Now let's take our analysis and visualize the results. Numbers are nice, but communicating results through visualizations can have a great impact. In this section, we'll look at several visualization libraries and when to use them. Creating visualizations from code makes them reproducible by anyone who views or uses your analysis, including your future self. The first visualization library we'll look at is Matplotlib. Matplotlib, originally written by John Hunter, is an open source project, also supported by the NumFocus organization, and is the foundational 2D Python plotting library in the Jupyter ecosystem. Matplotlib generates decent charts out of the gate and is used as the basis of other plotting libraries with more of a design edge like Seaborn. Matplotlib can be used outside of the Jupyter Notebook in scripts, in the Python and IPython shells, on web application servers, and more. Matplotlib should have installed with your Anaconda Python distribution. You will also need NumPy, imported as NP, to generate Matplotlib visualizations, which also should have installed with your Anaconda Python distribution. The Matplotlib website, matplotlib.org, is a great starting point for learning what is possible with the Matplotlib library. The website links out to many useful resources, including installation instructions, documentation, and a user's guide, an examples gallery, and a list of plotting commands, to name a few. One of the best things about the website examples is that the source code used to create the visualizations can be copied and pasted from the website, or downloaded as a .py file, or as a .ipynb or Jupyter Notebook file. When using Matplotlib in your Jupyter Notebook, always remember to use the Matplotlib inline cell magic to display the plot in your notebook. If you don't use the cell magic, your visualization will not appear in your notebook. The primary plotting command is .plot. We can create different kinds of plots, including scatter plots, line plots, and box plots. Here I've created a scatter plot comparing total population on the x-axis with total kilowatt hours on the y-axis. Now that you have a general sense of how Matplotlib works, let's visualize our analysis of mean energy usage by property type. First, we'll select building subtype and total kilowatt hours from our data frame and apply the group by method on the result, grouping by building subtype. Then we take the mean total kilowatt hours for each building subtype. Then, we'll save the result to the variable use by subtype. To see the output of our statement, we can enter the variable use_by_subtype in the next cell and press Shift-Enter. To plot the mean total kilowatt hours by subtype, execute .plot.bar on our variable use by subtype. In summary, there's a lot you can do in Matplotlib, and I encourage you to explore the resources on the Matplotlib website. Always remember to use the cell magic %matplotlib inline to display the plot in your notebook. Next, we'll look at Seaborn. Seaborn should have installed with your Anaconda Python distribution. If you installed Jupyter another way, then you can either conda install or pip install Seaborn. You will also need NumPy, Pandas, Matplotlib, and SciPy installed to use Seaborn. Seaborn is a Python visualization library built on top of Matplotlib that will help you dial up the aesthetic quality of your plots without needing to write complicated code. When using Seaborn, it is likely that you will invoke Matplotlib functions directly to draw simpler plots already available through matplotlib.pyplot. The convention for importing Seaborn is import Seaborn as SNS. To set the Seaborn style to the default Matplotlib style, add sns.set to the next line. Now with Seaborn imported, rerun your Matplotlib plots above. They will look nice. To further customize your plot, use Seaborn's themes. Here I'm setting the color palette to set 2. If I run this on my power consumption by building subtype and community area plot from above, Seaborn outputs the same graph but with a gray background, white grid lines, and a pastel color scheme for my bars. Check out the Seaborn examples gallery for more inspiration. Now we'll move to interactive visualizations with Bokeh. Bokeh is a Python interactive visualization library that targets modern web browsers for presentation. The goal of the project is to provide D3.js-style interactive graphics that can be scaled to very large or streaming datasets. Bokeh is still under development with occasional breaking changes as the development moves toward 1.0. Bokeh is a large library, and the Bokeh organization includes even more projects, including Data Shader and HoloViews. Bokeh itself provides two different levels of plot development. One is a detailed, low-level approach for highly customized graphics geared toward application developers. The other is a high-level library aimed at creating plots, or what they refer to as visual glyphs. You can follow Bokeh development on the Bokeh blog. If you are using Anaconda, Bokeh can most easily be installed by executing the command conda install -c space Bokeh. Otherwise, use pip install Bokeh. To get started using Bokeh to make your visualizations, see the user guides, and to see examples of how you might use Bokeh with your own data, check out the gallery. To use Bokeh in the notebook, use the standard imports, which are from bokeh.io import output_notebook, show, and then on the next line, output_notebook. Bokeh works with pandas, and we can use our energy data frame DF to recreate the scatter plot of total kilowatt hours mapped against total population. Here I'll use an example derived from Sarah Bird's PyData 2016 talk. Pressing Shift-Enter will render this code, and note it might take 10 to 15 seconds to render it as it pulls the data from your data frame. From here, you can use the Bokeh tools on the right side of your plot to pan and zoom in and out of your visualization. Save your plot as a static PNG file, refresh your visualization, and jump out to the documentation. Do take note that changing the view of your visualization by panning and zooming may be resource intensive for your system, especially if you are running everything locally. There's much more to Bokeh, including hover tools and time series animation, and I recommend diving deep into the Bokeh gallery to try to reproduce their visualizations and also the Bokeh GitHub tutorial. Bokeh is also available in R, Julia, and Scala. Plotly's Python graphing library makes nice, interactive, publication-quality graphics online for sharing and collaborating. Plotly has subscription-based and open-source options. Through its subscription model, Plotly offers several business intelligence and platform products and tiered pricing for students, individuals, and professionals. Plotly's open-source Python library provides all the plot types of Matplotlib, including line plots, scatter plots, area charts, bar charts, error bars, box plots, histograms, heat maps, subplots, multiple axes, polar charts, and bubble charts, and is free and open source. Creating a Plotly account is not required to use the Plotly for Python library. To install Plotly for Python, use pip install Plotly. See Plotly's API documentation for guidance on how to use Plotly's Python library.